In this video, I'll be repairing the horn system on a 1988 Porsche 944, as well as providing an overview of the primary system components and common troubleshooting steps. It's relatively common across the 944 models to encounter various issues with the horns on these cars, including intermittent functionality, part failures, and non-operational horn systems. The good news is that the system is fairly simple, consisting of only a handful of parts, so let's take a look at the main components. The vehicle's horn is operated by depressing the horn pad at the center of the steering wheel, and it's important to note that the horn will only function when the ignition is switched to the on position. Beneath the horn pad lies the path for the ground wiring, which consists of a horn contact ring attached to the base of the steering wheel, and a contact plate affixed to the steering column that connects to the relay control circuit. The ground connection passes through the firewall using the steering shaft, and it travels down the intermediate shaft linkage to the steering rack below the car, and the rack features a ground wire that terminates on the aluminum crossmember. If any of these components fails to properly connect, the horns won't work, and this is often found to be the source of many non-functioning horns. If the ground circuit is intact, however, and the horn pad is depressed when the car is on, it will activate the coil inside the horn relay that sits at position G13 on the central electrical panel. As far as operation goes, turning on the ignition supplies 12 volts across the horn relay coil terminals 85 and 86, and when you press the horn button, the horn relay coil is triggered, and that connects the relay switch terminals 30 and 87. The 12 volts sitting on terminal 30 is then passed through to terminal 87 on the relay, and then to ground via the horn's wiring, which activates the horns. There's also a 15 amp fuse for the horn circuit found at position number 3 on the fuse panel. If the horn relay or the horn fuse has failed, the horns won't function, but otherwise the circuit is completed and the horn wiring passes through the firewall by the brake booster and down along the frame rail, exiting just below the driver's side headlight assembly. The high and low tone horns are mounted behind the lower front spoiler, where they sit just in front of the wheel well liner. When troubleshooting horn issues, a number of tests can be performed to confirm functionality of various components. Starting at the fuse panel, a voltmeter can be applied by connecting the black probe to a suitable grounding point on the chassis, and then connecting the red probe to the following checkpoints. First, with the ignition turned off, we can confirm that there is battery voltage, or approximately 12 volts at the outside terminal for horn fuse number 3, and also that the fuse itself is intact. Next, the horn relay can be removed from G13, and battery voltage can be confirmed at horn relay terminal number 30. Now, with the ignition switch turned on, we can confirm that we have battery voltage at relay terminal 86. If incorrect voltage readings are found at any of these points, that would indicate a further issue with the wiring or the grounding points that would warrant inspection. But if these tests return the expected battery voltage, we know that the wiring to the fuse panel is okay, and we can move on to testing the horn functionality. At this point, the ignition can be turned off and a jumper wire applied across relay terminals 30 and 87, which should activate the horns. If the horns fail to sound, that would indicate a failure of the horn units themselves, or a faulty connection in the wiring leading to the horns. Moving down to the location of the horn units below the car, here we can assess whether or not they are properly connected. Each horn features 2 electrical terminals, and the proper seating of each can be confirmed. The horns are not polarity sensitive, so the placement of the positive and negative connections doesn't really matter, just as long as each horn has one brown wire and one black and yellow wire firmly connected. If the wiring and connections look good, the horns can be tested by applying 12 volts directly to the terminals on the horns, and it may be easier to do this with the horns removed from the car. To remove or replace the horns, the wiring will need to be disconnected and the 13mm mounting bolts removed. On the early cars, you'll likely find that the 2 horns are affixed to a single bracket where they sit side by side, and on the later cars, the high-tone horn points in a forward direction, and the low-tone horn points in a downward direction from the left body support. When replacing a defective horn, you'll find that these parts have been updated with an improved form factor, but they essentially work the same and they cost about $30 to $40 a piece. With the horn functionality verified, we can now perform some testing on the ground connections throughout the steering assembly. To troubleshoot the ground connections inside the car, the steering wheel will first need to be removed. We'll start by pulling the horn pad straight off of the wheel, disconnecting the ground wire for the horn contacts, and removing the 24mm mounting nut and wave washer. When loosening the nut, a support bar can be used by applying counter leverage on the wheel, and you'll want to ensure that the ignition is in the on position so that the wheel locking mechanism isn't damaged. With the steering wheel removed, the horn contact ring attached at the base of the steering wheel can be inspected. If the ground wire is broken, missing, or disconnected, the horn won't function. This part can be replaced for about $20 on the early cars and close to $100 on the later cars due to a part number difference. So unless it's completely damaged, it may be beneficial to try and repair the wiring. The contact surfaces can also be cleaned with a high grit sandpaper and some dielectric grease applied during reinstallation. As a side note, this part also contains a plastic tab on the back that cancels out the turn signal when the steering wheel is turned. For the following series of tests, an ohm meter and some jumper wires can be used to confirm the integrity of the horn circuit. First, attach a jumper wire to a known good chassis ground connection on the car, and the other end to the flat spring contact on the steering column. When the ignition is in the on position, the horn should sound. And this demonstrates that the horn relay, the circuit fuse, and the horn units are in good shape. Since we've already checked the fuse, the wiring, and the horns during our prior tests, if the horns don't sound with this particular test, it's an indication that the horn relay should be replaced. For the next test using the ohm meter, the resistance through the steering column can be checked. Go ahead and connect one of the leads to the jumper wire attached to the chassis ground connection, and the other lead to the center of the steering shaft, and here we should see a resistance reading on the ohm meter. If a resistance reading is not found, we know there's a problem with the grounding through the steering column that requires further inspection, and that area of focus should be the ground wire that runs from the steering rack to the crossmember, where we can confirm that the wire is firmly connected on both ends, and that the contacts are clean and free from oxidation. On the other hand, if a resistance reading is returned, we know there's a good ground connection through the steering shaft. The jumper wire can then be connected from the center of the steering shaft to the flat spring contact, and when the ignition is switched to the on position, the horn should sound. If this is the case, we've verified there's a problem with either the horn button or the horn contact ring, and those connections can be cleaned and the horn contact ring and wiring replaced if they're damaged beyond repair. Once you've completed any necessary repairs, the steering wheel can be reinstalled in the reverse of removal, and the 24mm nut is torqued to a value of 45 Newton meters or 33 foot-pounds. As for this 944, it was experiencing some intermittent horn functionality, and when the horn did work, it wasn't very loud. After inspecting the horn units, I found that one had oxidized so badly from the inside out that it had split the plastic housing, and a test confirmed that the high-tone horn had failed. So I went ahead and replaced both of the horns with some new parts. With the new horns installed, they were certainly sounding a bit louder, but there was still some sporadic functionality using the horn button inside the car. And when I removed the horn pad from the steering wheel to inspect the ground circuit, I discovered that the ground wire connector from the contact ring was pretty loose. The parts there were otherwise in good shape, so after crimping the connector with some pliers, the connection was tightened down, and now the horn has been working consistently.